Assalamualaikum warahmatullahi wabarakatuh. Hello guys, how are you today? We will present our presentation about titanium manufacturing process. Let me introduce you. My name is Dimas Sugianto and my friend Karim Wijayanto and Afrian. Next, we will watching a video about titanium manufacturing process. Happy watching guys.
First introduced into service in 1968, the SR-71 Blackbird has held the record as the fastest aircraft ever built for over 30 years. It was so ridiculously fast that if anyone fired a surface-to-air missile at it, the standard evasive procedure was to simply accelerate and outrun it. But when you build a plane that cruises this fast, you run into a surprising problem. The heat generated by aerodynamic friction on the plane is so extreme, if the plane were made from any ordinary metal, it would simply melt out of the sky. The solution was to make the airframe out of an extraordinary metal, which had never been used for this purpose before: titanium. Since then, titanium has become a vital material in the aerospace industry. The process begins with the extraction of titanium ore from mineral sand deposits. Mined from titanium-bearing sands around the world, these huge machines churn up sand and water and suck the mixture into a spiral plant, or wet mill. This works like gold panning, extracting the heavier black particles of titanium ore by allowing them to sink to the bottom. This ore is then further purified at the dry mill, where an electrostatic separator is used to extract the ilmenite ore from other trace metals. To be turned into a metal suitable for aerospace applications, it now needs to undergo a complex and expensive refining method called the Kroll process. Here at Henderson in Nevada, specialist firm Timit produced 22,000 tons of titanium products every year. The process begins by first turning the titanium ore into a gas. That's done by heating the ore to 1800 degrees Fahrenheit and adding chlorine gas to form titanium tetrachloride, known to the scientists as TiCl. As it cools, the tetrachloride is collected as a liquid. Now they need to separate the titanium and the chlorine. This is the really expensive part of the process, because to separate the titanium and chlorine, they have to introduce another expensive metal, magnesium. They heat the combined magnesium and titanium tetrachloride mix to between 1,500 and 1,650 degrees Fahrenheit for 4 days, causing it to react with the chlorine and separate it from the titanium. Once this is complete, the hot vessel full of titanium is craned over to another furnace. Here, a vacuum is created in the hot vessel which draws off any magnesium chloride. What's left is this, pure titanium, but full of holes, so it's called titanium sponge. They now have to turn this sponge into a usable metal ingot. The first step is to break the sponge up into smaller pieces. The freshly crushed granules are then sent along a conveyor to be tested for quality and ensure that there are no flaws. So they take a selection of granules into the lab and carefully inspect them using chemical testing and computer analysis. Once the men in white coats are satisfied with the quality of the granules, the titanium is ready to be turned into solid ingots. This first involves taking 330 pounds of granules at a time and pouring them into a tube called a compacting press. A plunger is then forced down the tube, and using 7,000 tons of pressure, it squeezes all the metal granules into a half-round compact block. These compacts are then welded together into a round form and melted down in a vacuum to turn them into an ingot. Now all they need to do is turn these blocks into usable metal forms. The blocks are heated in a furnace to a phenomenal 2,134 degrees Fahrenheit, the temperature at which titanium becomes malleable. These glowing metal sections are then removed from the furnace by a series of robotic pinchers and then fed into an enormous mechanical press. This fearsome beast uses thousands of tons of force to slowly compress the metal rod. and after several hours of concentrated compression, products such as titanium sheets begin to take shape. Finally, after a process of further heating, cutting, and polishing, the titanium sheets are finished. These sheets will be shipped to aircraft manufacturers around the world and used to make many of the major components, including jet engines, landing gear, and airframes. Thanks to this amazing metal, which revolutionized aircraft technology when used in the Blackbird, modern planes are now lighter, faster, and more fuel efficient than ever before. And all of this incredible technology began with a single grain of sand.
Titanium is widely used to make aircraft. This extraordinary warplane is the SR-77 or Blackbird, the fastest aircraft ever, with it could reach an incredible speed of nearly 2,200 miles and hold and climbed to 82,000 feet, but this monstrous plane would have been impossible without the extraordinary metal it's made from titanium. So how do they make this amazing metal? How do they do it? First, introduced into service in 1168, the SR-71 Blackbird has held the record as the fastest aircraft ever with forever 30 years. When you build a plane that cruises this fast, you run into a surprising problem. The heat generated by aerodynamic friction on the plane is so extreme. If the plane were made from any ordinary metal, it would simply melt out of the sky. The solution was to make the airframe out of an extraordinary metal which had never been used for this purpose before the titanium. One problem is that while titanium provides a higher performance than conventional materials at today's price, it's also 15 times more expensive than aluminum. The reason it is so expensive is because mining and refining pure titanium is incredibly complex process which takes up to 6 months.
The process begins with the extraction of titanium ore from mineral sand deposits. Miners from titanium-bearing sands around the world, the hook machines come up sand and water and sucks the mixture into a spiral path or wet mine. This works like cold planing extraction. The heavier black particles of titanium ore by allowing them to sink to the bottom. This ore is then further purified at the dry nodes, where an electrolysis apparatus is used to extract the ilmenite from other trace metals. To be turned into a metal suitable for aerospace application, it now needs to undergo a complex and expensive refining method called the Kroll process. The process begins by first turning the titanium ore into a gas that's done by heating the ore to 1,800 degrees Fahrenheit and adding chlorine gas to form titanium chloride. Second, separate the titanium and the chloride. This is the really expensive part of the process because to separate the titanium and the chloride, they have to introduce another expensive metal, magnesium. They heat the combined magnesium and titanium chloride mixed between 1,500 and 1,600 degrees Fahrenheit for 4 days, causing it to react with the chloride and separate it from the titanium. Once this is complete, the hot vessel full of the titanium is carried over another furnace. Here a vacuum is created in the hot vessel which draws off many magnesium chloride. What's left is this pure titanium, but full of holes, so it's called titanium sponge. They now have to turn this sponge into a usable metals ingot. The first step is to break the sponge up into smaller pieces. The freshly crushed granules are then sent along a conveyor to be tested for quality and ensure that there are no flaws. Soon they take a selection of granules into the lab and carefully inspect them using chemical testing and computer analysis.
The titanium is ready to be turned into salt ingots. The first involves taking 130 pounds of granules at a time and pouring them into a tube called a compacting press. A plunger is then forced down the tube and using 7,000 tons of pressure at square all. The metals ground into a half round compact block. The combs are then welded together into a round form and melt it down in a vacuum to turn them into an ingot. Now all they need to do is turn this block into usable metals from the phenomenal 134 degrees Fahrenheit, the temperature at which titanium becomes malleable. The glowing metals section are then removed from the forms by a series of robotic prints and then fed into an enormous mechanical press. This first time use thousands of tons of force to slowly compress the metals rod, and after several hours of concentrate compression, products such as titanium sheets began to take shapes. Finally, after a process of further heating, cutting, and polishing, the titanium sheets are finished. The sheets will be sold to aircraft manufacturers around the world and used to make many of the major components, including jets, engine, landing gear, and airframes, thanks to the amazing metals, which revolutionized aircraft technology when used in the Blackbird. Modern planes are new, like faster and more fuel efficient ever before, and all of incredible technology began with a single grain of sand. Thanks for watching, guys. Don't forget to like, subscribe, and comment. Wassalamualaikum warahmatullahi wabarakatuh.